All right, let's dive right in. Today, we're talking about a technology that is poised to completely change the game in medicine, large language models. Specifically, we're looking at how they're set to transform the world of radiology. So, let's kick things off with a classic quote from The Hitchhiker's Guide to the Galaxy. If you know the story, a giant supercomputer calculates for millions of years to find the ultimate answer to everything, and it comes back with 42. The only problem? Nobody actually knew what the original question was. And that, right there, perfectly sets up the challenge we face with AI today.
And that's really the heart of it. Getting a sensible, useful answer, especially in a field as critical as medicine, means you absolutely have to understand the tool you're working with. So think of this as your guide to getting a handle on large language models and how to use them the right way in radiology.
So, why the big focus on radiology? Well, because radiology at its core is a discipline built on language. Radiologists don't just glance at an image. They have to interpret it, connect what they see to a patient's entire medical history, and then communicate those findings with incredible precision. It is, fundamentally, a world of text.
And this is exactly where large language models, or LLMs, come into the picture. These are the AI systems designed to process and generate text that sounds human. So for a field that is swimming in patient records, imaging reports, and clinical notes, well, you can see why the potential here is just massive.
To really get this, we need to kind of pop the hood and see what's going on inside. So let's think of this next part as unboxing the technology, so we can see exactly how one of these AI brains is actually built. It pretty much boils down to 3 key stages. First, you have pre-training, which is where the model just learns the basic patterns and rules of language. Then there's instruction tuning, where you teach it to actually follow commands. And finally, you get to alignment tuning, and that's where it learns to be genuinely helpful and safe to use. This visual lays it all out perfectly. If you follow it from left to right, you can see the whole journey. It all starts with pre-training, where the model just inhales a huge chunk of the internet, learning one simple thing: how to predict the next word in a sentence. Then, in the middle, you get instruction tuning. This is where you make it useful by showing it tons of high-quality question and answer pairs. And finally, on the right, is alignment tuning. This is where humans get involved, ranking the AI's responses to teach it what a good answer really looks like. That 3-step process is what turns a simple word guesser into a powerful tool like ChatGPT. Okay, so we've seen how it's built, but what can this tool actually do in the real world? Let's look at how it can become a powerful assistant, a true AI co-pilot for a modern radiologist. And the applications are incredibly broad. I mean, on the clinical side, it could summarize a patient's entire lengthy medical history in seconds, or draft a preliminary radiology report. Operationally, it could help a department optimize its scheduling and equipment use. For research, it could sift through thousands of health records to find the perfect patient group for a clinical trial. And for education, it could be a 24/7 tutor for residents, walking them through complex cases.
But here's the thing. A base LLM is really just the starting line. We can actually equip these models with some powerful attachments. Think of them as power-ups that make them way more capable and reliable for something as serious as medicine. One of the most important power-ups is something called retrieval augmented generation, or RAG for short. This is how you make an LLM trustworthy. Instead of just relying on the data it was trained on, RAG lets the model go and look up information from a private, approved database, like the latest medical guidelines, before it gives you an answer. It's basically like giving the AI an open book test, where the only books allowed are the ones you fact-checked. And then you have what's called agentic workflows. This is a whole other level. Here, the LLM starts acting less like a chatbot and more like a project manager. As you can see in the diagram, it doesn't just answer a question. It figures out what you're trying to do, creates a step-by-step plan, and then uses other software tools like a calculator or a data analysis program to get the job done. This is how you start to automate really complex, multi-step tasks. Of course, with any powerful tool, you've got to read the user manual, right? It is absolutely critical that we understand the risks and the best practices here to make sure this technology is used safely and effectively, especially in a clinical setting. And we have to be honest, there are some very real challenges. Confabulations is a big one. That's the fancy term for when the AI just makes stuff up. It sounds plausible, but it's wrong. Data privacy is another huge concern. You don't want these models accidentally repeating sensitive patient data. Then you have the fact that they're not always reproducible. You can get different answers to the same prompt. And of course, there's the major risk that any biases in the training data get amplified by the model. This brings us to a really important choice. Do you use an open model or a closed one? Open models give you total transparency and control. You can even run them on your own local servers. But with that power comes full responsibility for security. On the other hand, closed models like ChatGPT come with built-in safety features and the developer handles privacy. But you get less control and less ability to see what's going on under the hood. The right choice really depends on what you need to do. Okay, so keeping all of that in mind, how do we actually get the best results? This last section is all about the practical, hands-on workflow for getting the most out of these AI tools in a medical setting. It all starts with the prompt you give the AI, and this is a fantastic picture of how that works. In round 1, you see a simple prompt gets a kind of basic, messy answer. In round 2, the user gets more specific and forces the output into a clear structure. By round 3, they've added very detailed rules about style and formatting, and boom, the final output is a perfect, department-ready report. It's not a one-shot deal. It's a conversation where you guide the AI to exactly what you need. And this slide right here really puts it all together. This is your optimization roadmap. You always start on the left with simple prompt optimization because it's fast, cheap, and often gets the job done. If you need the AI to be factually accurate and use up-to-date info, you bolt on RAG. And only if you have a super specialized task that these other methods can't handle, do you consider the most complex and expensive option, fine-tuning the model itself. So the big takeaway is, start simple. You know, at the end of the day, this is not about replacing human experts. The real goal here is to build a powerful partnership where the AI takes over the tedious, data-heavy work. That frees up the radiologist to focus on the things that truly require a human expert: complex decision-making, patient care, and that subtle, nuanced interpretation that an AI just can't do. And that leaves us with a final, really important question to think about. As these incredibly powerful AI tools become a core part of the medical team, how are we going to redefine the role of the human expert? What does it mean to be the expert in the room when your partner is an AI?